So here are our standards written up on the board. We've got about 7 of them for this packet, which is why it's a little bit bigger. We're going to graph for probably a week, okay, in different formats. So the first thing we're going to do is we're going to add a parent function. So far, we know how to graph lines. We know how to graph absolute value. We're going to add a quadratic parent function to that. Okay, and the parent function is x squared. Okay, it's not an exponent of 1, and there are no bars around it. That means it's not a line and it's not absolute value. It is a quadratic parent function. Okay, and we're going to start by just plotting some points. Okay, we're going to make a table of values. And I'm going to start from -3 to +3. And we're just going to plot the points and see what happens. Okay. This is a 9 by 9 square here. Okay. Now, because I have my table labeled, I'm not also going to write the points on the graph so I can see them here in the table. You should be able to either label your points on the graph or write a table so that I can tell where you're trying to plot them. All right, now this is a smooth curve. We call it concave up like a cup. There are no points. Nice, smooth graph. Now we're going to label the characteristics. Okay. I notice that this graph has, okay, this is the vertex. Similar to the absolute value, it is a max or a min based on the opening. Okay? Max or min based on how the graph is shaped. Right? I also notice that it seems as though the left half and the right half look the same. There is symmetry. This is your axis of symmetry, right down the middle of the graph. I'm just going to highlight the points that I think are the most important points, okay? Right here and right here. Because if I can find these points, I can use symmetry to draw the other 2 points. Okay, so we've got some vocab here. We have the vertex, and I'm just going to write it here. We have the vertex, we have axis of symmetry, which we have visually defined. We have shape called concave up. It's no longer a line. It's not linear. It's curved. How do I describe curve? We call it concave up like a cup. What do cups look like? Like that. Or concave down like a frown. What does a frown look like? Notice that those 2 pictures are curved. It describes how to draw the curve. Concave up like a cup or down like a frown. Okay? Other vocabulary words. I think that's good. Okay? So we're going to write down what vertex form is. Okay? Y equals A. parentheses, x minus h squared plus k. It looks kind of similar to the absolute value parent function, the transformation form. Good news, a, h, and k do the same thing. Except this isn't a line, it's a curve. So we're going to look a little bit closer on what a does to the graph. Okay, so here is our parent function. Guys, you have to memorize this. This is not something I'm going to give you. You have to know this shape. Okay, so y equals x squared, that's the parent. Much like you had to memorize the shape of the absolute value graph, you have to know this parent. As we go through the year, we will have about 8 different parent functions that you have to memorize. Okay? This is the second or third one. You consider linear, absolute value, and then quadratic. So this is the third shape of the graph that you need to know. Okay, so we have our A, our H, and our K. So let's look at our little Desmos link. I will show you. You don't have to open it. See where it has run off to. Okay, here we go. All right, boom. Okay, notice you have the parent here. Notice that I've highlighted 5 points. Purple, 2 red, and 2 green. Notice that I've only actually labeled 3 of them. The vertex, the purple, the red, 1, 1, and the green, 2, 4. Now I could keep going and label 3, 9, and 4, 16. Okay, but it didn't fit on the grid. Okay, so what we're gonna do is zoom back out a little bit. Okay, and let's center it. Let's drag our A value around and see what happens. Okay, so, okay. I need you to be able to tell me in words what the A value is doing. Okay, there's 0. Ooh, there's a 1. Okay, Drew. Okay, a parabola doesn't really have slope like a line, so kind of, but can you say it in a different way? It multiplies, but it multiplies. Joe, did you have a input? It stretches what? The y value. Okay, now look at what's happening here. Look at the x coordinates of those points. Look at the y coordinates. Only one of them is changing. Only the y coordinate is changing. Okay, so there's another. So we're stretching the y value. What else is changing? Somebody else. If you were trying to tell someone who was blind how to draw that graph and what it looks like, what else would you say? Concave up like a cup and concave down like a frown. Okay, or reflecting over the axes. All right, A value is the hardest thing to do. All right, so let's put it back at 1. Let's take a look at H. Okay, seems reasonable. Let's put it at 0. K. Moves it up and down. All right, let's do this. Where's the vertex? Yes, Gabe? Yeah, -2, 3. Look at the HK value. -2, 3. HK is the vertex, just like absolute value. You want to see something really fancy? Okay. Hold on. Can I graph it? squared. Okay, let me do this. I'm going to add something. Okay, what if I do this? Y equals a, wait for it, absolute value x minus h, absolute value plus k. It's the same thing, but it's a different shape. Oh my, you don't say. Guys, A, H, and K, same thing, no matter what the shape. You just have slightly different points that you're moving around. Okay, what if I do this? Y equals A, parentheses, x minus h, parentheses, plus k. It's just a line. Look what happens if I do A. Same thing. Now for the two linear graphs, the slope is changing. Parabolas do not have a consistent slope, so we can't say slope. We're going to say wider, narrower, skinnier, taller. Okay, different words. If I do this, notice that vertex, that's the point that's being transformed. That's the one that goes from the origin to the new point on the graph. Doesn't matter what shape. I said, you know, 3 parent functions. There's all 3 of them. Transformations work the same for every graph. You just have to know what graph to start with. Okay, let's go to our notes. Let's do an example. Okay, here we go. Let's make a note. A affects what? I'm going to say concave up, concave down. It's an abbreviation. That would be the opening. Open up or open down. Okay. Stretch Y value. Maybe I'll be more specific here. Concave up if A is positive. Concave down if A is negative. Okay. Up like a cup, down like a frown. H, right and left. I'll put a little note to myself, opposite. K, up and down, and maybe I make a note that the vertex is the HK. All right. Let's see if we can put it together. Graph. F of x equals 2 x minus 3 squared minus 8. Okay. Try it on your whiteboard first. All right, try it on your whiteboard first. Let's go ahead and let's do it in phases. See if you can first graph y equals 2x squared. Try 2x squared on your whiteboard. On your whiteboard. Here you go. Okay, 10 minutes of practice. Here we go. Let's see how many we can get right. Okay. All right, whiteboards. Graph it. Y equals x minus 3 squared plus 4. Jot down 3 coordinates, right? 3 points, vertex, and 2 on the same side. Graph it. You can do it on the open side or the graph side. Okay, hold it up if you got it. Yes, yes, yes. Nice. Yes, yes. I was trying to count points. Sometimes the grids are small. Okay, yeah, yeah. Nice. Okay, I will keep checking yours. I'm going to put up a new one. 3, 4, 4, 5, 5, 8. Right, so you can check your points. Dot, dot, dot. Right. Okay. Here we go. Y equals 1/2 x plus 4. That's it. 1/2 parentheses x plus 4. Quantity squared. Okay, if you get it, hold it up. Who's ready? You're making me count. That looked good, yeah. Yeah. Nice. Wrong direction. Yes. So what's the one? Right.
Hey, John.
I don't really use it. Right? So I'm going to find this one, this one, and this one. Okay. All right, let's try another one. Keep going, guys. If you don't get yours checked, I will come and check it. If you are not sure, guys, just raise your hand and ask. All right. Minus 1/3 x plus 1 squared minus 2. Okay, try it. If you are not sure, this is where you raise your hand and you check. All right, guys, hold it up if you've got it. Check the opening. Yes. 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 Yeah, there's really only like one easy point. You'd have to go all the way out to 6 to get another easy point. Yeah. You could do it, right? The more fractions you have, down to, but yes, okay. right, guys. Yes, good. And you could count it. I would do 3, and I would do 6. Yes. You count until you get easy points. All right, guys. We have 2 things left to do today. Can you write the equation in Vertex form of the graph that I'm going to give you? Okay? Here it is. You can do it. Remember, Vertex form has A, H, and K. Can you write the equation of an absolute value graph? Yes. Let's write the equation of a quadratic. 1, 2, 3. I think this is 3rd example. Okay. Write the equation of the parabola. And I suppose I will say in Vertex form. It does not have to be on graph paper because I'm just going to label 2 points. That's it. I'm only going to label 2 points.
Only 2?
Yep. Because technically you could get the 3rd. Okay. Let's go with this point is negative 2, 1. And this point is 0. 9? Sure, why not? And I'm going to draw the graph so you can tell. Okay, so visually, you can tell which one is the vertex. That's how I would do it. But I'm gonna show you the long way. Okay, so if I were looking at this, I'd be like, oh, how far apart is those points from that vertex? Which integer values am I going to use to stretch my graph to get to that point? That's what I would be thinking. Okay, so I'm going to draw, sometimes you call it a little loop triangle, whatever, doesn't matter. 1, 2. 2 units over from the vertex. How many units up? 8. I'm just looking at how far apart are my points. Can you guess the A value from that little diagram? Think of your parent points. What do you think the A value is going to be? If you got it, write it down in your notes. Okay? If you got it, write it down. It's a 2. It's a 2. It's supposed to be 2, 4, but I did 2, 8. How are you going to get there? Okay? Now, I'm going to do it 2 ways. First, I'm going to start by writing down what vertex form is. And then I'm going to plug in the things I do know. I know that the vertex is left 2, up 1. Y equals left 2, up 1. I'm like, oh, I don't know how to get my A value. Okay, we'll pick a point, plug it in. What's the only other point I gave you? 0, 9. Plug it in. 9 equals A. 0 plus 2 squared. Okay. So 9 equals 2 squared plus 1 equals 4A plus 1. Can I skip to A equals 2? Subtract 1, divide by 4. A equals 2. Yeah, okay, that makes pretty reasonable sense. So let's write it here. Y equals 2, x plus 2 squared plus 1. There's my equation. Can you do it in like a ratio kind of format instead? Yeah, let me jot down my parent points real quick. 0, 0, 1, 1, 2, 4. I mean, I wrote down a couple extra. I usually stop at the 2, 4, but it makes more of an impact that you're like, oh yeah, perfect squares. And I'm looking at it, and I'm going to highlight the things that are important. Well, the vertex, because I labeled a point that was over 2 from the vertex. And I have 8 units up, right? Over 2, up 8. Well, what do you multiply by to get that distance? You multiply by A. So 4 times A equals 8. A is 2. Guys, it's like skipping way ahead to the last step of your equation, because you set up a ratio instead. Okay. Try this one. Write the equation given. Vertex is 3, 0, and the point is 6, 3. 6, 3, 6, 6. Let's make it interesting. 6, 6. Okay, there you go. This time I didn't draw a graph. Write the equation in vertex form. Ratios lets you do it more in your head. I know. Sort of. Okay. Okay. So you see the point is 0. And solve for A. You're like, well, I know A is equal. Yes. 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 Nice. Okay, so show me the ratio of this, the equations that I can get. Just so you have something to show your work. But what did you do in your head? Right? What numbers did you compare? Just put them next to each other. Yes, yes, yes. Right? You got 2 ways. You can set up ratios. You can plug in the points and solve. So it would be 3, 9 is the one you're comparing. No, you didn't. It doesn't have to be named. Oh, that's because 6 minus 3 is. There you go. Not quite. 2/3. 2/3. Okay, so vertex form. Y equals A x minus 3 squared plus 0. The other point. 6 equals 6 minus 3 squared. I don't need to write plus 0. I got that. Okay. 6 equals A 3 squared. 6 equals A times 9. 6 over 9 equals A, or A is 2/3. Okay. Oh, ratio. Well, personally, I like the picture. 3, 4, 5, 6, 6. I think the picture makes it a little easier to be like, oh, 3, 6. Over 3 from the vertex, up 6. So really, 0, 0, 3, 9 times what equals 6. Exactly the equation right there. The ratio skips way ahead to the last step. All right. You guys are ready? That was the second to last skill. Here you go. Write the equation in vertex form. Okay, y equals x squared plus 6x plus, I don't know, what do we want it to be? 1. No, 9 would be too easy.
Come on, Mr. B.
Okay. Oh, that is standard form. We are going to use a perfect square trinomial, which is the same factor twice. Right? I need quantity squared. I need it to look like this. How am I going to get to a repeated factor? Means I got to make the perfect square trinomial.
Oh, yeah.
It says potential spam. Okay, perfect square trinomial. So here you go. I'm going to say factor A. Well, A happens to be 1, but I don't want to leave it out. We're going to complete the square, but we're not really solving. We're going to make our perfect square trinomial within the problem. You ready? Set up for your C value. Right? We can do it. Set up for the C value. Y plus this equals, okay, x squared plus 6x plus this. And I'm just sort of going to leave it. Do you see the similarities to what you used to do? I need to make a perfect square trinomial. Okay. What goes in my blank? It should be in unison.
8.
Let's just go 9. I get why you're saying 8. Let's just write 9. Okay? 9. 9.
Okay.
You can do 8. It's fine.
It works.
Yeah. Okay? Actually, do the factoring. Okay. Equals x plus 3 squared I don't really want this plus 9 over there. Can we subtract it back over? I don't really want a plus 9 next to the y value. I want it in y equals. So let's put it over. Okay. Do you see how this complete the square skill is being used in a not solving context? Make sure you are focusing on the equality of what we did. I added 9 to both sides of the equation. I factored and I put it in the vertex form. Okay. Write in vertex form, and I'll even remind you by complete the square. Okay, but I'm going to put a coefficient in there this time. All right. Y, I'll be nice. 2x squared minus
18.
Fine. No. 20. Sure. Why not? Okay. Guys, focus on equality. Make sure that whatever you're doing, it stays equal. Okay? I'm going to put a little line here. Make me focus on the equality of what you're doing. First step, factor A. I don't really want to divide A. You'll see why. Okay? I don't really want to divide A. I'm just going to factor it out. Leave a blank, guys. Leave a blank. Okay. 2x squared. Okay. Just look at what I did. I didn't really need to divide that 6. Why? I'm trying to complete the square on this piece right here. Keep in mind that I need a k value out there. So just leave the 6 alone. Okay? What do I need to do next? I actually need to, okay, well I've set up for my c value, and I need to find my c value. You're good, I'm just making more room. Just squeeze it. Okay. I didn't leave room for that next to my y value. How do you feel about that? Is that okay? Think about your balance. If I add something, but then I also take it away, am I still equal? Didn't I just minus this 9 over up here? What if I just leave them on the same side of the equation? Okay, fill in the blank. Half it, square it. Now I'm going to do a little pencil step here. And I'm just going to redistribute my 2 real quick. How much did I actually add to this? No, how much did I actually write in? It's really a 50, guys. Do you see that times 2 in front? It's really a 50. This first set of parentheses is multiplied by 2. So when I put in a plus 25, I was really adding 50. Means I really need to minus 50. Okay. Right, guys, we're still completing the square, but you need to, it's not a memorization. You just need to pay attention to where your coefficients are and what you're actually doing. That's why I went forward, but I left a room for me to go a half a step backwards to be like, oh yeah, what am I actually doing? I need to put a minus 50 out here. That's what I really need to do to make sure that this is equal. See it? Go backwards one line and redistribute and make sure it's going to work. Oh, add 50 minus 50. Good thing that's equal. Okay, now let's actually finish completing our square. By leaving everything on one side of the equation, there's less steps involved. All right, I'm going to give you your last one, and then we really are done, and you can start working on your homework and things like that. Okay. Write in vertex form. Okay, there you go. Okay. All right, factor the A. Notice I'm leaving myself a little bit of a break in between. Okay, so let's highlight what I'm going to do. I'm going to plus it in here. I'm going to minus it out here. Now I think I want to put a 4 here. Okay, this is, first I do this 3, second I find this 4. And then I'm just going to go back real quick and redistribute. What I really did is I added 12. So I really need to minus 12. That's 3 times 4. It's the distribution, guys. That's what you're really subtracting. See? That's my middle step. See that pencil? That's what I wrote in to help me check what I was doing. Right? I went forward a whole step. I went backwards a half step to check what I needed. Okay? And factor it. Okay.